Hello everybody, my name is Rohan Lakhan and today I am going to explain you guys a very interesting topic from my subject computer graphics. So the topic name is Bresenham Line Drawing Algorithm and it is the most used line drawing algorithm because it's the fastest among the two other line drawing algorithms that are DDA line drawing algorithm and one more is खैर उसको छोड़ो so Bresenham is the fastest among those two, and it uses integer calculations and the codings and things when we are solving the questions. So let's get started with the programming. Sorry, presentation. So yeah. So the introduction to this Bresenham line drawing algorithm, like where did it came from, who built it, and things related to it. So yeah, Bresenham line drawing algorithm is an efficient method to draw a line between two distinct points, and it is proposed by Jack Bresenham in 1962. Uses only integer arithmetic like addition, subtraction, and bit shifts. It's ideal for raster devices where pixels are placed on grid. Why is it important? Like everyone asks that why are we using Bresenham line drawing algorithm instead of using DDA and those other line drawing algorithms? Why we are using Bresenham only? So we are using it because floating point operations are slower in hardware in this with this, and Bresenham eliminates the multiplication and division. It provides smooth, accurate, and consistent lines, and it is widely used in games, graphics, CAD, and embedded systems. That's the main reason. That's the four main reasons why it is important. So how do we handle this different slopes? That when we are solving the question of Bresenham line drawing algorithm, finding a slope and then doing the calculations like finding the parameters and putting it into a table and then changing the parameters every time means changing the points of xy and finding the 2 points for drawing a line on the graph. It's a thing. So there are two major cases which I have mentioned in this presentation. That are case one says that if the slope is smaller than one, it's a gentle slope, and x increases by one each step. The y increment conditionally. And the case 2 says that if the slope is greater than 1, it's a steep slope. So here in this case, y increases by 1 each step and the x increments conditionally. Going further in the Going further with the slides, it says the mathematical background that how are we going to solve a question of Bresenham algorithm. So we are So when the question they always give us the two coordinates x1 x2 x1 y1 x2 y2. So we find the slope first. So how do we find slope? So the formula for finding slope is it's a very simple formula that says m is equals to y2 minus y1 divided by x2 minus x1. That simply will give us the values for dx and dy. So the similar thing is been written over here in the PDF in the presentation. Sorry. So yeah. So when we find the slope, we get the numbers, and after that we find after that we find the parameters, and this is the simple parameters what the thing is written here, as you can see. And if you want, you can take a screenshot of it and try doing it by yourself. Later, after some time, I'll explain my own done question to your guys, if in case you want from me. So the general algorithm that I've taken from GFG, it says I have my own version though, but I have decided to go with the GFG's version because I wanted to sound more legend. Yeah. So the general algorithm of Bresenham algorithm is to calculate dx and dy, determine the dominant directions x and y, initialize the decision parameter p. For every each step, plot pixel at x and y, update p, and update x or y based on the parameter p. And then the last step says that continue until destination point is reached. So it's the method that has been set by GFG, but the method that I use that my teacher taught me that says that find the slope, then go for the parameter things. Check the slope. Is it smaller than or equal to, or it's greater than equal to 1 or 0. So yeah, after that we simply built a table where we mentioned the x1, y1 and x2, y2's plot numbers in one column, and the next remaining two columns has the parameter values, like the next step, the next points that have been plotted over this graph. Like if I say that I'm starting from a point one here in the this is x-axis and this is y, and if I am going through a coordinate system like from 1.1 say like around I think for example 7.7 tak. So how many points have been located in these 2 points? So how many points are going to come in this two? So we find these points that will help us connect these 2 points here, 1.1 and 7.7. 7 comma 7, sorry. So it's a simple thing. It's a very simple thing if you pay attention to your teachers, what they are taught, what they are teaching you. It's a very simple thing to understand. So yeah, we put those two coordinates x1, y1, x2, y2 into the other two remaining columns, and after that we replace it with the new one. And this procedure just keeps on rotating until the last coordinate which has been given into the question. As I said, for my example, it's 7 comma 7. So you will stop when your last coordinate in the table will come as 7.7. You have to leave that question there. That's the only thing you have asked to answer. So yeah, moving further with the slides here. So yeah, if your teacher says that write a pseudocode for your examination, so here I've written this code for you all. So just copy it and just give it a try by yourself. I've tried it myself and it works very well. I forgot to I forgot to mention that screenshot of my VS Code, but it works very well. And as I said, there's one example that says line from 0 comma 0 to 6 comma 4. So yeah, we have did the thing. We have find the slope dy by dx and sorry. Then we have find the parameter and we have created table. There's some mistake with the table. Uh, must be some glitch or something which but I have created a labeled मतलब कि अच्छा वाला टेबल ग्रिड वाला forget it आपको समझ आ गया fine. So what are the advantages of Bresenham line drawing algorithm? So as I said, it's faster than DDA algorithm because there are no floating points in Bresenham. It works well on all raster devices. It produces visually very smooth line and very accurate predictions sorry and very accurate points and very smooth visual. It's easy to implement in hardwares also. So these are the four advantages of Bresenham algorithm. And so we have talked about the advantages. So we have to talk about the limitations. We have talked key its goods and bads. So now it's time for the bads of Bresenham. So the limitations. What are the limitations of Bresenham algorithm? So cannot handle. So it cannot handle anti-aliasing, does not support thick lines directly, more complex for generalized classes, circle and ellipses. And what and where we can use these applications. So in computer graphic libraries, in game development, mostly we use it in game development. Another thing as well. But if you ask me for from my perspective, I only use it in the game development things because I love this creative things which you do by coding and things. So yeah, the third thing is vector graphics rendering and CAD software and embedded hardware drawing routines. And so, what's the conclusion of this PPT? So, what's this Bresenham in short? Bresenham algorithm is the most efficient line drawing method. It uses integer arithmetic only. The third one says it forms the basis of many advanced computer graphic algorithms. Let me repeat this line very carefully. It forms the basis of many advanced computer graphic algorithms. So yeah, that is for from my side. Yeah, my presentation is over now. So yeah, my name is Rohan Lakhan, and this is my presentation about the Bresenham line drawing algorithm. Tell me in comments how did I how did I presented this algorithm, and hope you all liked it. Tell me in the comments and don't forget to hit the like button. Thank you.